Let's take a look at the difference quotient. I think your best bet is to just think of the difference quotient as the slope. We've called it slope, we've called it rise over run, some of you have called it m. We have the difference in y's over the difference in x's. So delta y over delta x, some of you may have used that notation, you call it m. We know that we can switch the order of each of the numerator and denominator, the difference in y's over x's, to be this instead. And if we use the same ordered pairs, just use the different order, you get the exact same number. You should try that with some numbers. We've called it rate of change, and now we're going to call it the difference quotient. We have different names for a variety of different reasons. One, to keep life interesting, and also we typically use them in different scenarios. And so we're starting to call it the difference quotient in algebra because we're heading somewhere. And at the end of the video, we'll talk a little bit about that. Before we move to the difference quotient, let's remind ourselves of function notation. When you have an ordered pair like this, the first one is the x-coordinate, the second one is the y-coordinate, and this is just the function notation for the y-coordinate, and it's saying take the value of x, which is a, substitute it into the function, and get your y value. Second one, take the function f, take the value of b for the x value, and substitute it in the function and get your y value. So we still have the difference in y's over the difference in x's, it's just in function notation. So we have to understand that first before we go to this crazy notation. And the crazy notation, I think, is a little more difficult because we use x's in it as instead of just a's and b's or subscripts. And so now we're just saying here's a variable, here's its y value, which you would get if you substituted it in. And then x plus h is saying I'm just a little to the side of x. I'm not x, but I'm just a little to the side. Now, a little could be a big number or a small number. It could be left, could be right. But whatever it is, it's different than x. And when you substitute it in the function, you get a y value. So the difference quotient is still the difference in the y values over the difference in the x's. So y2 minus y1, that's this. x2 minus x1, that's this. And that's where the x names come in really weird. And you simplify the denominator and just get an h. So h can't be 0. In other words, x plus h cannot be equal to x. So when you're asked to find the difference quotient, they're really just asking you to use those two ordered pairs, some value of x, and then a little to the left or right, x plus h, their y values, and find the slope between them. Now, you don't get to just pick x values here. When you're asked for the difference quotient, you are actually literally using x and x plus h. Then you use the function they gave you to actually find some expression for this y value. Let's do a linear function. Find the difference quotient of f of x where? Here, linear function. So our ordered pair, x f of x, ordered pair x plus h, f of x plus h. So f of x is just this guy. Let's go ahead and write that in. So we just keep him 3x minus 2. For the next one, x plus h, if you were asked to find f of 2, you would put 2 in here. 6 minus 2 is 4. If you had 17 here, you would put 17 in, multiply by 3, and subtract 2. But we don't have a number, we have an expression. So we have to take the whole x plus h and put it in for the variable. So let's do that. We're going to get 3 times, and we're going to put our x plus h in there. And that's going to give us, distribute 3x plus 3h minus 2. This whole thing is f of x plus h. So let's substitute it into our difference quotient. We get f of x plus h is 3x plus 3h minus 2. We're going to subtract our original function, and our original function is 3x minus 2. And let's go ahead and simplify. 3x plus 3h minus 2. Distribute the negative sign across there, and you get negative 3x plus 2. Watch that positive sign. And then at this point, we're going to be able to add some things to 0. Positive 3x minus 3x add to 0. Negative 2, positive 2 add to 0. And what we have left then is just 3h over h. And those h's divide out and give you 3. So the difference quotient for this particular function is 3, a number. Now what happens if we have a function that is not linear, something different. We're not just going to get a number from this thing. And so f of x is exactly the way you see it, so let's go ahead and put x squared minus 3x plus 1. And then the same argument as before, we're going to take the whole x plus h and substitute it in for each of the variables. This is going to take a little bit more work because we're going to square it. We're going to multiply it by 3. We're going to have to do some simplification here. X plus h, x plus h. Okay. So the first term, x plus h times x plus h, gives you x squared plus 2xh plus h squared, because it's really the quantity x plus h times x plus h, and you FOIL it. Now take that negative 3 and distribute it in, and then that plus 1 comes along for the ride. That entire thing is f of x plus h. Not pretty, but it'll work for us. We're going to substitute it in here. Then we're going to subtract the original function. Use parentheses, right? So let's go ahead and do that. We're going to substitute in f of x plus h. So we get x squared plus 2xh plus h squared minus 3x minus 3h plus 1 minus the original function all over h. So let's put that original function in, which is x squared minus 3x plus 1. And we got that. This is what was given. Here we have it in our little table. We're going to distribute this negative sign across, and I know it's going to be really tempting to just start slicing and dicing through here. I recommend you write it again, because this is the step lots of students make errors on, and it's algebra at this point, folks, so let's not make a mistake because we're being sloppy. Distribute the negative, and negative x squared plus 3x minus 1 all over h. Okay, and let's see what happens then. We get, sorry, wrong color, positive and negative x squared add to 0, negative and positive 3x add to 0, positive and negative 1 add to 0. And so let's go ahead and rewrite. We get 2xh plus h squared minus 3h is all that's left in the numerator. Now notice there's an h in everything, so let's factor an h out. What times h gives you 2xh? 2x plus h minus 3 all over h. They divide out. So what we're doing is what times h gives you this, what times h. So we're pulling out a GCF, right? So divide those out, and that gives you then your difference quotient, 2x plus h minus 3. This guy is not just a single number. He's got a variable in it, and it's got that h in there still. And so when you're doing difference quotients, you could even have powers on this. These can get really ugly with high powers, and you can have coefficients in front where you have to multiply in as well. So be aware when you're simplifying this f of x plus h that this could get really bad, and slow down there to make sure you don't miss anything. So let's look at the graph and see why these two functions have different looking difference quotients. The first one on the left was our 3x minus 2. Well, that's a line. Remember, a difference quotient is just another name for a rate of change or slope. And on this, a line, the slope is the same everywhere. And the slope is, you got it, 3. And so it makes sense that the difference quotient is 3. But for the one on the right, this is not a line, it's a parabola. It is a quadratic function, and so it is facing up because it's got a positive leading coefficient of 1. And so at any given point on this, the rate of change of this parabola is different. And you can imagine there being a bunch of lines or tangent lines, think of them coming along here. And how would we find the slope of each of those? You would pick an x value and a point very close to it, so x plus h, and so you would have 2 points, and then you can find the difference quotient with those 2 points, and that would be the slope of the tangent line between those two. Now what's really interesting is that when you get to calculus, you are going to find difference quotients, and then you're going to take the limit as h gets to 0, so these 2 points get really, really, really close, and then It just drives out then the rate of change or the slope at that given point. And from there, you get your derivatives. So that's what's coming in your future at some point. I hope everyone is having a great day.